Welcome humans to ETC Tutorials. So in this video we are going to be learning about a couple things. Actually, let me go ahead and just drag my text file over here so you can see my notes for what I wanted to teach everyone today. So we are going to be learning about gravity and physics, and basically gravity and physics, and mostly physics. So first we're going to learn about the difference between mass, gravity, and drag. So this has to do with objects dropping and how fast they reach the ground and the differences between all of those things and how they work. Then we're going to learn about physic materials. So basically this is kind of like how you put a material on a game object to make it look like it has a certain texture to it, or just make it look like a certain color or something like that. Physic materials are like the same thing, except it's the material of what that thing is made out of. So you could create a physic material for like a cinder block or a piece of iron or a bouncy ball and stuff like that. So that is one thing we're going to be going over. And then we're going to learn how to add force and add torque. So add force is a useful function that we're going to be using inside of JavaScript. And that is basically for things like if you want to shoot fireballs or something and make them fly and bounce around. Basically it's adding force to something. And then we're going to learn how to do add torque, which is the same thing except rotation instead of movement. So we can do stuff like we're just going to take a cube and we're just going to make it go wee and spin, basically. And then we're going to learn how to change gravity through code. I'm also going to show you how to change it in the inspector. And then we are going to learn about how physics work in slow motion. So we're going to briefly talk about slow motion, and this is going to be, well, mainly the main thing that you got to think about with slow motion is physics and how physics are going to work in slow motion, because other than that, it's just a matter of changing the variable time scale. So why don't we start with the difference between mass, gravity, and drag? So let me show you the scene that we got set up so far. It is from the previous tutorial, which was about light mapping and first-person cameras and 90 degrees and stuff like that. So basically we just have, when we turn on the game, we can look around in this scene. So let's add some physics to it. I'm thinking let's add some spheres, and let's put that in a better place, that somewhere that we can see. There we go. That's good enough. So we will call this sphere regular. Actually, yeah, sure, whatever. Sphere regular. We're just going to do a generic no physic material. So we're going to go to add component, physics, rigid body, and now when we give the game a run, the sphere should simply just drop to the ground like that. But let's do a couple of things and edit how this sphere is going to behave. So actually what I'm going to do is I'm going to create a couple of spheres, and I'm going to name them different things, and I want them to behave all kind of differently. So I guess the first thing we should talk about is mass and gravity, and then we will get into drag. Well, why don't I go ahead and just sum up what all three of these are. So mass is how heavy an object is. So this will affect things like if it collides into a bunch of really light objects, like if you have, let's pretend like all my little fingers are really little BBs or something that are small and light, and this is a big asteroid. When it comes, it can be moving slowly, but it's going to knock these things away, and it's just going to continue moving because it has a lot of mass. Now, having more mass doesn't necessarily mean that something is going to fall to the ground quicker. I believe, who was it, Newton or something, Newton's law of gravity, all objects fall at the same gravity or something like that. I can't remember, but basically all objects will fall at the same speed no matter how heavy they are, except for when it comes to drag. So in real life, drag is basically wind resistance. So when you drop a feather, that feather doesn't really have much weight to it, but it's really light and fluffy, and the air that is around the feather has to travel really, really far to get all the way around that feather. So the feather has to push through all of this air, and it doesn't have very much mass to push through that. That is drag. So it is dragging through the air. It has to, I mean, that's the best word I can think of to describe how that works. It's dragging through the air. So something like a feather would have a high amount of drag. So that would be probably what you'd be thinking of if you wanted to say the difference between a hammer falling and like a feather falling. I think that's what was it Galileo? Maybe I don't know my history, but so that is the basics of gravity and mass and drag. So let's create. Like, I'm actually going to take all of these and I'm going to duplicate them one more time. And what I want to do is create like a pool of rigid bodies down here so that we can demonstrate something with a lot of mass and how it is going to affect lost my train of thought, and how it is going to affect like when you collide into objects and stuff like that. So I guess I'm going to delete that, and let's go ahead and just have two. Actually, no, I'll delete that. I'll do it one at a time. I think that'll be the best way to do it. So let me just move my camera so that I can see where it's going to fall. So I want it to fall like right there, and then it's going to knock kind of all of the balls outward. So actually, you know what? I changed my mind. I do want two balls to fall at the same time, so I'm going to duplicate that. All right, so let's take this one and let's name this sphere large mass. And let's take this sphere and name it small mass. Small mass. All right. So large mass and small mass. So we will change this and have it small mass have a mass, and you change it right here in the rigid body component. We are going to have it be, I don't know, let's something really small like 0.2. And then we're going to take this one and we're going to make it much larger, like something like that's really, really large. So let's go ahead and run the game and see what happens. Okay, so you could kind of see that, but let's see if we can see it a little bit better. I'm actually going to move these all up. I'm going to take all the sphere regulars and move them a little bit closer to the ground. I don't want them colliding with the ground, just to be really close so they don't fall as much. And actually, you know what? I'm going to take the camera and I'm going to move it backwards just a little bit so that we can see it better. So as you can see, they fall at the same speed, and the heavy one, the one with the large mass, knocks everything away, and the one with the light mass hardly does anything. It kind of like knocks over the other ones because it doesn't have enough mass to push through those other rigid bodies. So let's go ahead and play that just one more time just so that you can see it. So pay attention. They both, I sound like a teacher. Pay attention. They both fall at the same speed, but yeah, so that's the basic premise of the idea. Now let's go ahead and change them. Instead of large mass, we are going to call this large drag. And where's the other one? We will call this small drag. Like I said, it doesn't really matter. I don't have to be renaming these, but whatever, staying organized. So let's select these both at the same time. Let's give them both a mass of, say, 10. And then let's select the one with large drag, and let's give it a drag of, I don't know, 5, maybe. A lot of physics in Unity is just a matter of trial and error and seeing what happens. So as you can see, that is how to make one of them fall faster than the other. So that is basically how drag works. The larger that number is, the harder it has to push through the air, and also the mass is going to help it push through the air faster. So if I give this a drag of, say, a mass of 100 and a drag of 5, I think they're going to be a little bit more balanced out now. Maybe not. I don't know. But whatever, that is physics. All right, so what is the next thing we should talk about? I guess gravity. So let's try increasing gravity and see what happens. Actually, I want to change this to have a mass of 10 once again. And then let's go to Edit, Project Settings, Physics, and then this is where we are going to change the gravity. And as you can see, it has an X, Y, and Z. So in Unity and in just physics in general, and I'm sure many other video game engines, but as far as Unity goes, gravity is not just downwards. Gravity is a number that represents a direction, and in this case, negative 9.81. So 9.8 meters per second squared is the accelerating force of gravity on Earth. So that means 98 meters per second per second. That's why it's per second square. So the speed of every game object in the scene is going to increase at 9.8 meters per 9.8 meters per second and is going to increase at that speed, and it's really acceleration, and in this case it is downwards. But if I were to change this to positive 9.81, we're going to have the exact opposite gravity, and you will see that everything kind of floats up, and that is the direction that gravity is going now. We can also, let's change this back to a negative number so that everything goes down. But if we change this to a larger number, if I'm thinking of my physics correctly, I believe it should all fall faster. Yes, that was faster, right? I'm pretty sure that was faster. Let's add a 0 in there just to be sure. I'm pretty sure they'll fall really fast now. Bam, yes, okay. So I was correct. So yes, the larger that number is, the faster they are going to fall. So if I set this to -1, it's gonna be like we're on the moon. Actually, you know what? Let's do something really cool. I'm going to pull up, stupid MSN, I'm going to pull up Google, and I'm going to say, what is the gravity on the moon? The gravity on the moon is 1.622 meters per second square. So I was pretty close when I guessed 1. So if I do 1.622, now our game has actually very realistic gravity if we wanted to make a moon simulating game. So yeah, that's basically how gravity works. And so I guess I'll play it just to show that is what's yeah, that looks just like the moon, I guess. Whenever you see footage of people walking on the moon, that's kind of what it looks like, right? I don't know. But let's say that next to the moon, there was another planet that was a little bit bigger than the moon. And let's say everything moved across the x-axis at 2. So now we have a bit more of a direction to our gravity. So it doesn't have to be just up or down. It can be in any direction. So if you happen to want to make a game that has some sort of crazy gravity puzzles or something along those lines, that's pretty much how you would do it. Okay, so on to Physic Materials. I guess for these, I'm going to delete these 2 game objects, and I want to take all of the regular spheres. Actually, you know what? I want to delete, let's see, can I do all but 4? Yes, I'm going to do that. I want to delete all but 4 so that we can get some different Physic Materials and find out what kind of cool stuff we can do physics-wise. And I'm going to slant this floor so that we can also see how things kind of have friction and stuff like that, because like the physic material of a bar of soap would be way different than the physic material of, say, a cinder block or a brick or something that's going to have a lot of friction and not slide across any surfaces. So to create a physic material, you just go, actually, let's see, is there more than one way to do it? I don't know. You can go to your project window and, okay, you can click on this create button, or you can right click on the asset folders and go to create. Either one, they're both the same. There might be one other shortcut to do it, but whatever, I don't have it memorized. This is how I do it. We are going to, there it is, physic, oh, you can't see it. So I gotta move my, nope, not what I wanted to do. I gotta move my Unity. Then I'm going to go to right click, create. There, now you can see it, physic material. So we're going to click on that. And then we are going to move Unity back so that you can all see it just fine. And new physic material, let's rename this cement. That is, actually, I'm going to, just for the sake of everything being alphabeticalized, physic material cement. There, that way it will be all nice and alphabeticalized. Okay, so we have stuff like dynamic friction, static friction, bounciness. I actually probably should have looked these up, but I'm pretty sure, well, dynamic friction and static friction. I believe dynamic friction is the friction at which there is friction if the game object is already moving, and static friction is if it is coming from a rest. I assume that this would be for stuff like Jello, or no, what's quicksand or something like that, where like once it gets going then it can slide a little bit, but it maybe something that's sticky, like a really sticky can of soda or something that's stuck to the surface of a table. It's gonna take a little bit of force to get it sliding across something, but then it will slide easier once it starts sliding, basically. So cement would have a pretty high dynamic friction, so let's give it a friction of, I don't know, 0.8, because it can slide a little, but it's not like glue or anything like that. But the static friction we want to be 0.9. I don't know. I'm really kind of just guessing here. Actually, since we're going to be putting on a sphere, it's just going to roll. So I think I'm actually going to put it on a cube and see how it behaves on a cube. Bounciness, though. Actually, instead of this, I'm going to first do the physical material of a bouncy ball. Sorry, I'm being really ADD and just jumping around. That's kind of what happens when you wing tutorials like this. But I'm going to call this bouncy, whatever. Bouncy, whatever. So the friction of that will be pretty much the same, but let's set the bounciness to 0.9 because we want it to be super bouncy, and we have some other things here that might be useful. Like if you want to make something that has absolutely no friction, I know that friction combined you want to do either multiply or minimum. I think minimum is the one that works a little bit better. I think they actually both behave the same once you set the friction to absolute 0. So if you want like a physic material that's going to defy actual physics, or just in other words be super slippery beyond all possibility, then you'll want to set the static friction and the dynamic friction to 0, and then set this setting to either minimum or multiply. So yeah, so let's go ahead and give the game a run, and I forgot to apply it to any of the balls. Actually, no, I'm going to go to the camera and I'm going to disable this look script because I'm tired of it moving around. I don't really care about it moving around. So let's go to sphere regular right here, and let's call this sphere bouncy. Alright, so I think there are 2 ways that you can add a physical material to a game object. One is you can just drag and drop it anywhere, like in this downward area of the inspector, or on to the game object listed in the hierarchy, or you can drag and drop it in here in the collider where it says material, physic material. You can drag and drop it there, and then also you can click on it and it'll show you what physic material is on that game object. So let's go ahead and run the game now and see what it looks like. I forgot the gravity was sideways, so let's go ahead and fix that. But I could definitely see that it was nice and bouncy and it looked pretty cool. So let's go to physics, and let's set this to 0, and let's set this to negative 9.8. 9.8. All right, cool. Let's go ahead and play it again. And you can see that that one bounces just a little bit more. Let's go ahead and take that bouncy material and let's set the bounciness to 1. And then let's set the bounce combine to maximum. And this way we will get the maximum amount of bounce. So basically now it's just ignoring all other physics, and it just goes bounce this much, the most amount of bounciness, basically. I don't know. So that is how you would do that. Let's see. Let's actually, I want to delete these. I'm going to hit delete, 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 and I'm going to create, let me zoom in on this so that it creates it in the right spot for me. I'm going to create a cube. I'm going to move that over. I'm going to call this cube regular, and then I'm going to duplicate that, and I'm going to move this one over, and I'm going to call this cube cement. Cube cement. So, oh, I also got to add rigid bodies to those. So physics, rigid body, and we should be set. All right. Cool. So this one here, so by default, there is a default physic material. You can actually edit that inside of edit, project settings, physics, and you can edit, wait, is this? Oh no, that's something else. Okay, so you can create, let's say I wanted all physic materials by default to be bouncy. I would drag and drop this physic material right here, but there is a general physic material that is automatically applied to all game objects, so you don't have to worry about there not being a physic material. It's just that if you want to customize the physics of a particular game object and how it interacts with other game objects as far as friction and bounce, then you're going to need to create a physic material. All right, so where was I going with that? Okay, cement, physic material, cement. So now cube regular has the default physic material, and cube cement has the cement physic material. Actually, did I finish editing this? Yeah, it has lots of friction. Okay, cool. Let's go ahead and play it and see what. Okay, that wasn't cool enough. Let's first of all make these a little bit longer so that they don't roll. So let's make them like that. All right, so instead of cube regular, I'm going to call this cube slippery. And let's create, whoops, let's duplicate that and call this physic material slippery. And let's go ahead and drag this on top of cube slippery. And now when we play the game, oh, I forgot to change it to anything. Okay, so let's go into the inspector. Dynamic friction, 0, 0. Friction combine, minimum. And now that one should slide. Yep. So there you go. That is how to make something slippery. Cool. So that is pretty much all what we need to do there. So let's go ahead and now learn how to add force. I guess how should we do this? I guess I'm just making this up as I go. Just making it up as I go. All right. So let's go ahead and give this a rigid body. So physics, rigid body, and let's not use gravity. Let's make it so this object is just suspended in space, and that should work for our purposes. So I'm going to call this cube add force. And now I'm going to duplicate it. Actually, is there already? No, okay. I just thought there was another game object there. So now let's call this one add torque. Torque. I hope I spelled torque right. I know I have legendary spelling skills. So now we are going to create 2 scripts. So let's go here. Let's go to create JavaScript, and we will call this add force. And let's go ahead and duplicate it and rename it. Whoops. Add torque. All right, cool. So what we are going to do, actually, we need to go to the input manager and make it so that this only happens when, actually, no, we can just use jump. We can just use the space bar by default. So we don't need to set up anything in the input. So let's go to add force, and I think if I'll just, you can, okay. Form a sentence, Etiski, form a sentence. Okay. Let's create some variables for how much force we want to add. So we'll just call this force amount float, and let's have it by default be 100, something like that. A nice tip about physics is if you are not sure if it's working and you're not sure if the physics are actually being applied to your situation, try setting the numbers and the amount of force or torque that you add to objects to a really, really high number. And if your game is working, the object or whatever it is will just fly off the screen and it will get way, way too much force. But if it's getting way, way too much force, you at least know that it's getting some force. So I find it easier to start from a high number and go down to find the number that I want, as opposed to starting at 0 and going up, because oftentimes when you start at a lower number, like say 10 or something, sometimes you can't see the force that's being added because you're not adding enough, and you might think that your game is broken. Whereas if you're adding too much force, you're like, oh, it's just too much force, just got to pull it back. So that is just a random tip that I thought that I would throw in there. All right, cool. So let's add an if statement inside of the update loop that says if input dot get button down. Whoops, no, wait, where's just regular get button down? But there it goes. Get button down, and we are going to do jump, which is by default the space bar in Unity. And if we do that, then we are going to do rigid body, and we don't want to do capitalized, so rigid body dot add force. Did I spell that right? I guess I really don't know. And I guess we need to actually put a vector 3 in here. So I'm going to change this to a vector 3. Actually, I changed my mind. This is going to be a vector 3 because you need to use a vector 3 for adding force to a game object. So we're just going to do force amount, and I'm actually not sure if I wrote that right. So let's go ahead and go into Unity. I got some errors. Expecting something found. Oh, okay. Oh, I need a parenthesis right there. Okay, so maybe now I got it right. Let's see. Looks like I did. All right, cool. So let's go to, is this the add force? Let's add the add force script to there. Force amount. Let's do, let's see. Let's do -20 on the z-axis and see what that does. Bam, not that much, but I can press it more and add more and more. So that's how to add force to an object. Let's set it to +200 so that we can see what that looks like. So it's just going to go bam, like that. And then let's also, I mean, I'm sure you guys get the point by now. So let's set that to 100 so you can just see that you can add force just in directions of different amounts. And actually, I'm going to show one more thing. I'm going to do add relative force. I hope I spelled that right. Let's find out. Did I spell it right? It looks like I spelled it right. Okay. So I'm going to stretch this so that you can kind of see, and this is going to be Z forward. I'm going to make this game object shoot forward. So this is really useful for things like bullets or rockets or fireballs or things like that you want to shoot out of a gun and you want to go in a specific direction. You would use add relative force. So I'm actually going to rotate it like that. And then I'm going to do 0, 0, and then 200 on the z-axis. So if I run the game, let's see what happens. I press spacebar and it shoots. So awesome. And I can use gravity, and I can, if I press it, sort of did a little something. Actually, if I set it to more like 2000, I press the spacebar before it hits the ground. Bam! So that's physics. All right. Now let's go ahead and make, actually I'm going to take away that add gravity thing and change that back to 200. I guess that really doesn't matter. Now let's go back to mono develop. Actually, I got to go to Unity. I want to edit the add torque script. So add torque, once again, we're going to do a vector 3. So var torque add vector 3. All right, cool. And we are going to do, just like in the other script, if input.get button down jump, jump, then rigid body, and make sure it is lowercase because we are referencing the rigid body that is attached to the game object that this script is attached to, as opposed to referencing the rigid body class. We want to access a very specific rigid body, not just rigid bodies in general. So that is why it is lowercase and not uppercase. So dot add torque. And I'm just going to skip over add relative torque. I'm sure you guys can figure that out. And was it torque add? Torque add. And that should be pretty much everything that we need to do. Whoops, I broke it. All right, there we go. So add torque, drag and drop this game or that script there. Torque add. Let's make this rotate around the x-axis at a speed of, I don't know, 360, something like that. I don't know. And when I press space, then it spins like that. So that's pretty cool. All right. And then actually what I'm going to do is I'm going to increase the angular drag so that you can see how angular drag works. So I'm going to press it, and then it's going to slow down because it has angular drag. So remember, drag and angular drag are a little bit different and can be used in different situations. But typically, if you're doing something like a feather or something like that, then you're going to increase both the angular drag and the regular drag, or just drag, let me just go ahead and point it out so there's no confusion. The drag and the angular drag, you're probably going to want to increase both of them. But, you know, it might be different in different situations. It's just variables that you have available to you that you can play with. All right, cool. So let's learn how to change the gravity through script. And I might as well create one more JavaScript. So create JavaScript, and we will call this change gravity. And actually, before we jump into this script, I'm going to go to Edit, Project Settings, Input, and I'm going to add a new button. So let's just change that number to 16. And then down here, we will rename this to Gravity. Okay. Positive button. Let's have the positive button be E. Why not? That's a good letter, right? Okay. So what I'm going to do is, I gotta double click it in here. So change gravity script. And how should we do this? I guess I will do if input dot get button down. We are going, what was it? Gravity. Then gravity. The name of the button was gravity. So if we get the gravity button down, then we will do physics. I believe it. We need to do capital physics dot gravity lowercase equal. So the reason why physics is capitalized is because we're talking about physics everywhere. Basically, we're talking about the class physics, and we're just talking about the engine, so that is why it's capitalized. And then gravity is lowercase because gravity is a variable that we are going to change, as you are about to see. So let's have it when we press the E key, gravity is upside down, and when we let go of the E key, gravity is normal. So vector 3, 0, comma 9.8 comma 0, and just like that. So that is upside down gravity, because remember on 9.8, positive 9.8 on the y-axis is upside down gravity. All right, so now let's do if input dot get button, and let's change this word down to up, and then put a little negative in there. We should be ready and working. So let's go ahead and just drag and drop that on any game object. I just threw it on a cube. It's just, I don't even know which cube. Actually, we'll find out. It doesn't matter. I just threw it on a random game object because it's just affecting our entire scene and not one particular game object. So let's play the game. If I press E, everything goes upside down. If I let go of E, everything that did have gravity should be falling back down. And actually, what is this? The cement. So let's click on this static friction. I believe the static friction is too high. Maybe that's why it's not flying back up into the air. So let's set the static friction at 0.5 and see if I'm correct. I could be totally wrong. If I'm wrong, I'm just going to continue on with the tutorial. Okay, I'm wrong. I don't, that's bothering me. Why is it doing that? I don't have drag on there. I use gravity. Whatever. I don't care. I'll figure it out later. Somebody will let me know in the comments below why that object wasn't flying back upwards. Let me try this one more time. Okay. Okay, there we go. Now it's going up. So it hits the thing. Now it's going back up. All right, whatever. Maybe it was the friction thing, but whatever. That is how to add force, add torque, change gravity. And now we are going to look at gravity in slow motion. So let's also make it so that when we are going upside down, we will also make the game go 0.1. We'll make it go 1/10 the speed that it normally does. So let's add some brackets so that we can add multiple commands inside of the if statement, or more lines of code. You know what I'm saying. All right, so we will do time scale equals 0.1. And let's go ahead and copy that. And let's add a bracket. And let's add that. And let's just change it to 1. So now that way we just have it. Let me separate those. If we get the gravity button down, otherwise E, then the time scale. Now basically this is a number that represents like 1 is normal speed, 0.5 is half speed, 2 is double speed. So it's the speed at which time is moving. So if we press that button down, we're going to be moving at 0.01, and if we let go of the button, we're going to go back to 1. So 1/10 speed, full speed. So that is how that is going to work. So let's go ahead and save that, and let's go in here, and let's go ahead and run the game and just see if it works. It works, and you can see it is really, it's frame rate dropping, I guess, is the way that you could say it. Now, you might be, actually, why don't I go ahead and click on stats just so that you can see in case you don't believe me. So when I press E, it looks like it's moving at a frame rate of like 1 frame per second, or I don't know, 3 frames per second. It's going way too slow that it doesn't even look playable. But as you can see up here, we're moving at a very quick 60 frames per second. So this is a perfect frame rate. The game should be moving really smoothly. So you might be asking yourself, why is that? Why does that happen to rigid bodies when you go in slow motion? Well, the answer is if you go to Edit, Project Settings, Time, this right here, time, no, not time scale, fixed time step. This is the problem right here. So this is the fixed time step, and this is basically the number of seconds that the engine waits in time multiplied by the time scale. So if we're moving at half speed, it's going to count at half speed. So basically, this is the number of seconds that the engine waits before it re-updates the physics. So if we have this set to 0.5, the physics are going to be updated 2 times a second. If we have it set to 1, the physics are going to be set to 1 time a second. And in our case, we have it set to 0.02. So I believe that is 50 times a second. So when we set the time scale to 0.1, that's 1/10. So really it's only updating 5 times a second. So that's why it looked so slow and jittery like that. So we are going to change this number to something like 0.02. Let's make it go 10 times faster to compensate for the way that it was looking before. Just note that this does take up more performance in some cases. I think there might be some sort of like a ceiling for some certain situations. I know I have played games, or I have made games where I've set this to a really small number and nothing really that bad happened. Like I didn't really have that many performance decreases. Well, actually thinking back, yes, I did. So anyways, so yes, if you want to increase your performance, set the fixed time scale to a larger number. But if you want your physics to look really good and realistic and move at a really fast frame rate, set it to a smaller number. And you got to find that middle ground between what looks good and how fast your game is running. So let's go ahead and give it a run and see what it looks like when I press E. So as you can see, now it is moving at 1/10 the speed, but it is doing so at a very good frame rate, and it actually looks nice and smooth. One thing to note, and actually I will play the game again, is that it won't, like, things like add force and add torque won't shoot as fast. You are going to have to rebalance all of your variables as far as how fast and hard things shoot when you change your fixed time step. And there are ways that you can do in code, but I'll save those for another episode because that's a little bit more advanced and a little bit tricky, and this video has kind of gone on for long enough. So hopefully that will give you all a good understanding of physics, and if you were looking to do physics, that's how to do physics, and whatever. That was all the information I got for today. So you either liked the tutorial or you didn't. I don't know. I will see you all in the next video. Until next time, humans, keep making games. Oh, I gotta press the button. I'm so unorganized. All right. See you all later. Keep making games.